Hanford's cleanup plans might someday include a process called vitrification, in which tank wastes are immobilized by turning them into a solid glass-like substance that can be stored in stainless steel containers. In this glass-like form, the waste is impervious to the environment, and its radioactivity can safely dissipate over hundreds to thousands of years. Bechtel National Incorporated was hired to design and build the Hanford Tank Waste Treatment and Immobilization Plant, also known as the Vit Plant. The construction, which began in 2002, is scheduled for completion in 2023 and has a budget of $17 billion. The U.S. Department of Energy, or DOE, hopes to solidify the 56 million gallons of liquid radioactive waste now held in 177 underground storage tanks. Since each tank has a different combination of radioactive and toxic substances, vitrifying Hanford's waste poses many challenges, as Gary Petersen will explain, followed by John Fox and Tom Carpenter.
The nuclear waste at Hanford is unlike any other site. It's not like Savannah River, it's not like Oak Ridge. They tried different processes to speed up the production of plutonium. And so they had a variety of different ways that they would remove the plutonium chemically. And so no two tanks are alike, and there's 177 tanks, so no two tanks are alike in the composition that's in those tanks. And so it becomes a very complex problem. So the 177 tanks out there have all different chemicals in those tanks. So as you get to the tanks and you want to solidify it, turn it into glass, you have to have a plant that can take any composition of the material and mix it and do it safely in zones that you may never be able to go back into. And so it has to be almost 100% fail-safe before you start. And so that's why the waste treatment plant has taken so long. That's why it costs so much.
All of that means we've got a much more complicated situation to face, and it's exacerbated by adoption early on of this so-called black cell design for the Vit Plant, which was adapted from a British approach, which says you build this thing so you don't require any pumping and mixing and things that require maintenance. Everything's driven by pulse pumps pressurized by hydraulic or pneumatic pressure to move things around. So you don't ever need to go into the plant to maintain it. Well, you can never answer all the reliability questions that get raised.
I'm pretty pessimistic about the approach they've taken and how they've painted themselves into a corner with the waste treatment plant. You know, one of the design issues was in the 90s, the Department of Energy hired the British to design our waste treatment plant. And they used something called black cell design. Black cell is called that because they take all these nuclear processes that are supposed to separate nuclear waste in a huge room, the size of a football field or 2 football fields and as high, just loaded with tanks and pipes and equipment. And once you seal it off and start it up, you don't have lights in there. You don't have entries into there. You can't get in to inspect, to repair, to replace equipment that's failed. It's supposed to operate for 45 years with no inspection, no repair, and no replacement. So if something breaks anytime in there, a pipe breaks, it contaminates the whole facility. You now have this huge, highly radioactive facility. What's that going to cost to clean up? Nobody knows, right? And the facility's useless. If not worse, it may be a safety threat as well.
Hanford's current plan for handling tank waste is based on British success. However, Hanford's task is more complicated because of the variety of radioactive and toxic mixtures in its 177 tanks. 4 major nuclear facilities and 20 supporting facilities are now being designed. If all goes well, the process will be underway by 2022 and then take about 40 years to complete.